Cool. So did anyone stay drinking until the morning and came directly as we were doing when we were young? Please raise your hand if you did. No one. Okay. So hello everybody, my name is Francesco Puppini, and today I have a presentation that is quite original. The title is Untangling Data Complexity, the Power of Graph Theory as a Cost-Efficient Data Solution. So I have to say, it's not about graph databases. So it's all about normal databases like relational, but with the help of graph theory, we can find something out that is very cool. So before starting with the serious things, let's start with a fun fact. So the fun fact is about my first visit to Scalefree in Hanover, because it was in 2019, and it was my first time meeting the team here in Scalefree. And yeah, I wanted to share this with you because I believe that it's a picture of how beautiful this collaboration is. So yeah, this is the fun fact. It's me with the team. Actually, we have today we have Mark, and yeah, this is me and Mark in the reality, and that's the fiction. So basically, I came to elevate my knowledge. You see, I'm climbing, and actually more than that. The fun fact is that Mark is the second smallest in the group, which does not happen very much to Mark, I guess. And today you were the first smallest, and I was the second smallest. Okay, cool. So yeah, about myself, I'm a consultant in business intelligence, and yeah, especially in this community, it's very useful to point out this, that I am a consultant very much in the front end part of the business intelligence, while a lot of people think that I'm a data warehouse guru. I am certified in Data Vault, yeah, but my heart is always in the front end, in the presentation layer, and that's quite relevant in today's presentation. So I was working also on Data Warehouse. I worked for Teradata because I wanted to understand why the source is sometimes so messed up. So I went to work with Teradata to find out, and but a lot of Click, Tableau. And then now I'm working with Astrato. I'm a consultant with Astrato. Astrato is a company that is doing a software of business intelligence from scratch, from zero. So that's quite interesting how they are trying to compete with the giants, but we are doing some very good stuff. And the things that you are seeing today, the concept that I'm presenting today, are implemented in Astrato already in production. So you can test them tomorrow or this evening. Then I'm also collaborating with the university, Bologna Business School, and I wrote a book called The Unified Star Schema. But today I don't talk about that. I presented this book already 2 years ago here. So we are going a bit beyond. So it's stuff that is even more cool than the stuff that is written on the book. Okay, so this is the Astrato, the home page. So just that you know. So there's a software that has this graph theory inside. Okay, a slide to the Bologna Business School. This is the university where I've started teaching, and yeah, also fun fact. This was it's just next to my home in Bologna, and it was the kindergarten of my sisters. So they were going to this building as a kindergarten, and then later it became a university. Okay, so the agenda of today. I will talk about three things. The first will be graph theory. And the second will be cost inefficiencies in data projects. And the third one is basically how to use the first to mitigate the second. All right, so I think that many of you know about graph theory, so we will dedicate just 10 minutes to that. And then cost inefficiencies in data projects, I wanted to allocate the right amount of time, so it will be 7 hours. So brace yourself, I hope you're comfortable. And then there will be no more time left, so you will never know about the solution. But maybe if I keep it shorter, I will be able to speak about the solution as well. Okay, so part one, graph theory. I guess many of you know graph theory started when a Swiss mathematician, Euler, went to Königsberg, which is a city of Prussia, now Russia. And he was walking around the city. And that day, he was clearly not too busy, because the biggest problem that he wanted to solve on that day is how can I cross all the 7 bridges only once. That's the problem that he had on that day. So the bridges are the ones in yellow, of course. And he was trying to run from the first to the second and so on. He was doing all the combinations, and then he said, wait a minute, why am I running? Why don't I build a theory and I solve it on paper? So, yeah, is it possible to cross each bridge only once? And okay, here I made a few examples. If you start from the north bank, you cross the first, the second. Okay, probably I can use the mouse. You cross the first, the second, third, fourth, fifth, sixth. But then after the sixth bridge, you are in the middle of the island, and you cannot cross the seventh. What did you say?
You can swim.
Roberto, I knew that you were in this presentation, and I knew that you will raise your hand and you will say this stupid phrase. That's why I said without swimming. I knew it. Okay, I made a second example. If you start from the other bank, no, actually from the island on the right, and you do that tour like that, you arrive to the north bank. Now, Roberto, do you have to say something more about north bank and how to reach the south bank?
You can fly.
No, I didn't put that one, but good one. Actually, I wrote without walking until the source, because that's the river. At some point, there must be a mountain, so you can walk behind. But no. And also, I will add, thank you, I will amend the presentation, and I will write, you cannot fly. Okay, so the graph theory was born. So basically, the idea is that Euler said, okay, instead of running all the time in the city, I just pen and paper, and I just make a schema, so an abstraction. I create 4 vertices, so vertices are these balls, violet balls, and 7 edges, like 7 bridges. And then this way, he could focus on the solution of the problem directly on paper. And yeah, think about that the first two, actually B and C, the ones in the middle are islands, but the others are North Bank and South Bank, but still, you can treat them as islands. So I actually went to check on Google Maps, and yeah, basically the city is up here, and this is actually an island. It's not interesting, but I was curious and I checked it. So is it possible to cross each edge only once? So I repeat, edges are the lines and vertices are the islands, let's say. And I remind you, it is allowed to cross the same vertex multiple times. That you can do. What you cannot do is to cross the edge multiple times. So the answer is no, it's impossible. Actually, this is an example. It's not relevant to our presentation. It's just to show you that by doing this abstraction, it's possible to think of a solution that is general. So he said, okay, now I want to understand what are the conditions that make it possible to cross each bridge only once. And he was saying, okay, basically, when a vertex has 3 edges, well, you once go, you come, you go, but then you cannot come away. So basically, life is easy when the number of edges is even, 2, 4, 6, and so on. So the problem is when it's odd, because it becomes a trap. But then he said, okay, but I can at least, I can start from an edge and never go there back, but then I need to arrive to the other edge. So at least I need to have either 1 or 2 edges that, that's how it is. At most, 2 vertices can have an odd number of edges. So this is the solution. So basically, if that is, if you count the edges, they are 5 and 3. So if instead you delete a bridge, now an edge, then this one is no longer 5, it's 4. This one is no longer 3, it's 2. So this way, 2 vertices have odd number of edges, yeah, A and C. So that is possible. So if you look at this example, you can start from here, and you can go around, and then you can go like this. And yeah, I'm lost. Wait a minute. You start here, you do this, 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 and this. So this way, yeah?
We don't see the mouse.
Oh, okay. Do I have a pointer? Yeah. Which one is that? No. That was not the mouse. I don't have many buttons, so how many chances? Okay, thank you so much. So basically, yeah, if you start here and you do this, sorry, I'm lost now. I don't remember anymore how it is. 1, 2, 3, 4, 5, 6. Yeah, this way it works. So yeah, actually it's not very relevant for the presentation. It's just to show you a general thing. So one odd vertex will be the start and the other will be the end. And this way the problem is solved. So how do we use the graph theory in practice? A typical example is Google Maps. So in Google Maps, what is happening, each crossroad is a vertex and each street is an edge. So basically, that's the same concept. So you generalize, you abstract, and then you can play around with Google Maps. For example, all the algorithms, the most famous is the shortest path. That is, minimizes, initially could be the distance, but actually there's a general concept of weight, which in this case, it's a mix of time, money, and even impact on the environment, because if you check here, the one suggested is the one of 8 minutes, although there will be a shorter one, which is 7 minutes, but they adjusted the weight in a way that the number of kilometers is very important. So when minimizing the weight, it turns out that the best solution to go from Hotel Hanover to the train station is to go that way. So it's an example, this shortest path of an algorithm that is used for Google Maps, but it can also be used for other applications. So there are several types of graphs. And the most important is that, for example, in real life, sometimes you cannot use a particular edge in one direction. You can use it in one direction, but not in the other. So, for example, if the street is one way, then you can have cases like, for example, they are all two ways, but this one is one way. So you need to have an abstraction that keeps into account that some edges you can only cross in one direction and not in the other. So there are directed graphs and undirected graphs. Directed have arrows. Undirected, they have basically double arrows, or no, it's basically lines that you can cross in both ways. According to the problem that you want to model, you will need to decide what type of graph to use. And what happens if you choose the wrong type of graph? Well, if you are in a city center which has one-way streets, and then you choose to model the problem with this undirected graph, well, at some point the driver will receive an instruction, turn right, and you cannot turn right because it's a one-way. So if you model a city center with the undirected graphs, well, your model is not good, and someone will say, okay, this application doesn't work. So you need to choose the correct model whenever you are using the graphs. Okay, so there is a wealth of resources available, and this is becoming relevant to what we are going to cover. So there are definitions in graph theory. There are a lot of definitions, and then there are theorems, and then there are algorithms, and then there are libraries. So definitions, you can go to Wikipedia and find all this definition. I just took a screenshot of a part of page A, and it arrives until Z. So a lot of definitions there. And then theorems, so I don't know all these theorems. It's a lot of material. It's crazy. And then graph algorithms, that's the most important. So someone had an idea how to solve a problem. As we saw earlier, the one we saw at the beginning was an algorithm. It was a general rule. And actually, algorithm is more than that. It's also a way how you calculate these things. And finally, libraries, which are specific for languages. So I found a list of Python libraries, but every language has libraries for graphs. So the advantage of the abstraction is that all these resources exist in an abstract and generalized form. So the people who create a software library, they have no idea how that resource will be used. So someone does the job for you. They create a library, and then you use it for something that they would have not even imagined. Maybe something in biology. I have no idea. So there is Google Maps, we said. But I found some screenshots. I found, for example, the submarine cables in the ocean. They can be represented with graphs, and then someone can make calculations. What's the best way to send a package of data? Or social media. I think you've seen this image a lot of times. Social media are using graphs quite a lot. Okay, so graph theory can be used in many different domains. And that's all. So this was about graph theory, but we have the concept that some things are reusable in many domains, and that's what we might need in the part 3 of the presentation. Okay, data projects today are too expensive. I will not speak 7 hours about this, so I chose a topic. There are many reasons, but this is the one that I want to address today, the operator. So does any of you recognize this image, what movie it comes from?
Pretty woman?
Yeah, the Italian guy. He doesn't say, sometimes he says good things.
That's why you told me to come.
Exactly. So that's Pretty Woman. This is the guy in the lift. And why do I like so much this image? I put it in a lot of presentations. It's because when we take the lift, we don't need to press, we don't need a person who is pressing the button for us. We can do it on our own, right? So the lift is self-service. Sorry for the shoulders. I've been told to watch on that side for the camera. So you go to the lift and you use it on your own. You press the button, okay? So the operator, to me, is that person that is receiving a salary for doing something that you should do yourself, okay? So in the lift, they chose it because it's fun, whatever, or in the past it was needed, but now you don't see it anymore. But you still see it in projects of business intelligence. So my dream, whenever I started doing business intelligence in 2001, is, okay, I was saying, I'm receiving a salary, I am the operator, I'm receiving a salary to do this, but it's such a waste of time. I was always searching the solution that is general, that is always working, so instead of me being there, some machine is doing that, and I'm spending my time on the beach. I don't know with what salary, but that's a different problem. But I believe that when you do this, I mean, the operator does not get fired, just the operator will do another job that is more clever, more interesting. Maybe this guy is a doctor, or maybe he's a mathematician, and he only finds a job to press the button to go to the floor. So I believe that the operator should stop doing this job and should do something more interesting. Okay, to create a report from this is a normal data model. This is the data model of AdventureWorks from Microsoft. Many of you know this database. An operator is needed. You cannot tell a business user, okay, go there and grab some sum of sales amount and the region and just put them together and the report is done. They need an operator. This is the problem that we have today. And I like also a lot to show this image. This is an image I found on the internet, and I added the phantom layer. So how is that? Basically, you have your data sources, you have your data warehouse that can be a data vault or something else, staging area, core layer, data mart, and the designers of the data mart, they say, okay, after that, it's ready for consumption. But it's not true. So here are the BI tools. Here in the middle, there is a layer that you never see in the schemas. But I've worked in the industry since 2001, and every time that someone was proudly saying, yeah, the data marts are ready, so the business users are happy, well, I was doing all that job of adapting the data mart to the actual needs of the business user. So there is always one additional layer of calculation that no one talks about, but it's there. By the way, if someone has, we don't need to necessarily do the Q&A at the end. If someone says, I don't agree, you, the first Italian guy here, no. But if someone doesn't agree, you can also raise your hand. So my experience is that this calculation layer is always needed. Okay, that's my experience. And today, every business requirement is a project. So you need to allocate a budget, allocate resources, and the business users need to wait some time. It used to be months, now it is just weeks. Sometimes, if you have a very smart team, it can also be days, but it's a project. One thing that is sure that it hasn't changed today, there is business intelligence with self-service to some extent, but still, it's always a case where, almost always a case where the business user needs to ask for help from some technical person. Or you have it full self-service if your data set is very simple. Sales, clients, product, okay, you do a star schema. They can drag and drop what they want. They have the total freedom. But the business is never just one star schema. That's the point. In the moment when you want to put 2 or 3 business entities like orders, invoices, shipments, and stuff like that, well, you have the report for the orders. You have the report for the invoices. Within the report, you can play around. But the thing that, let's say, for example, the dimensional modeling of Kimball never resolved is that when you have the star schema for that and the star schema for that, well, you still, business user, cannot merge them on your own. That's why I wrote a book, The Unified Star Schema, where everything gets unified. But still, I wanted to go beyond, because the real self-service means that a business user can do any query that is using the elements that are available. Because projects are expensive. So every time that there is an allocation for a report, it's money and time. I was trying, I Googled for images for money and I found that. And then I Googled for time, but I didn't find an image for time. And I Googled for frustration, and I also didn't find an image of frustration. But imagine that there is always time, money, and frustration. So the goal is to build a self-service analytics solution ready for business users. So what is the audience of a data warehouse? The audience of a data warehouse is these two guys. You know these two guys, right? So I noticed that most of the data warehouse books mention the IT users as the target users. So even the book of Data Vault, it says a lot, and then the user can do a join with the statement, like a between statement. Well, these are the guys who are doing a between statement, not the business users. So in general, the data warehouse is a massive work, but still it needs the last mile to be done by an operator. That's my experience. Then you can tell me your opinion. So instead, this should be the audience in a data warehouse. So these are, you see, they're girls, they're nice. There is a creepy person there. I don't know if you see. That's the IT guy. This should be the audience of a data warehouse without any help from that creepy guy. So you see. So why don't we give them full access to everything pre-joined? So this is a real question for you also, because I need a glass of water. If someone can give me a bit of water, please. So can you tell me your opinion? Let's do it a bit more like a brainstorming thing. Why don't we give them everything? Just give them all so they can drag and drop happy ever after. I know you want to speak. Let's see for a second. So why? I mean, we have, thank you. We have the self-service in e-commerce in a lot of domains. So why don't we? Like, what's wrong with business intelligence? Why we don't give them full access to everything, pre-joined, ready to use? Be brave.
Too many combinations.
Too many combinations. Who said that? Yeah, hey. So too many combinations, that's a good one. But, okay, that can be, but you can handle really a lot of combinations when you have the lucky scenario where you can do the full self-service. Still, there are millions of combinations, and you can still do it, like a star schema. How many? If you have 1,000 columns per table, you still have a lot of combinations, but you can have full self-service with a star schema. So in my opinion, it's not about too many combinations. I need someone else to say it so I can think.
Performance.
I like this. So when it comes to performance, I'm always making the example. Okay, but if you have a database with 3,000 rows, well, that's very small. So no matter what you do, you will never have a problem of performance with 3,000 rows. However, or 10,000 or whatever. However, also with a database that is very small, who said performance? Sorry. You. Also with a database that is very small, where you for sure don't have any problem of performance, you still cannot give them the full freedom. Okay, so there are a few reasons that I found why you cannot give them full freedom, because in some cases you have multiple ways to join two tables, like you can have the orders and the clients, and with the orders you have the build to, ship to, and sold to, so you have 3 ways of making this join. So there are many reasons. But the real problem is that in self-service data analytics, some combinations of data elements don't make any sense. That's the biggest problem to me. So if you give to the users a pool of dimensions and measures, and they drag whatever, okay, blindfolded, I drag this and this, they will end up making combinations that don't make any sense. So I have a question for you. Which one of the following queries is bad? I call it bad. Sum of sales amount by client country. Sum of stock quantity in the warehouse. by product category, and sum of stock quantity by client's country.
We'll take the last one.
We have one first opinion, the last one. Anyone else?
No one.
So you can also do the last one. Okay? They're shy today. Okay, my opinion is that the last one is wrong. So,
For me, okay, if you don't put conditions, because the sales amount can be different currency, for example.
yeah, sure. But which one of them has no hope to make any sense?
That's the
Yeah, okay, sorry for the phrasing. Always the Italian guy, just that you know it's always him. But the question is why? Why some of us think that sum of stock quantity by client's country doesn't make any sense?
If it is still in stock, you don't have a client.
Who is speaking?
If it is still in stock, you don't have a client.
If it's still in stock, you don't have a client. That's exactly the thing.
I disagree. I think it depends on your context. So, for example, on Amazon, I have a 2-hour agreement that I'm going to ship anywhere in Toronto, and the stock quantity is 0 in Toronto, but the stock quantity in the United States is 1,000. So, knowing how much is in Canada, or knowing how much is in a small country like Belgium, is absolutely critical in that domain. So, you can come up with I have to think you can come up with an example where all three of those queries make sense.
Okay.
All three of them are bad ideas.
Thank you, Scott. I really like that you're saying this because actually I like this approach. So you are saying there are cases where it makes sense. I like that. Okay, so this is a forum. I'm just bringing my opinion here. So I really like that we do it as a forum. Fine. So how can we help users avoid asking bad questions? So at least, Scott, one question for you. Do you agree that in some cases with some particular data models, that question is impossible to solve?
Oh, yeah.
In some cases. Okay.
Either way.
Yeah, exactly. So there are, in any case, I think we all agree that in some particular scenarios, like also Roberto said, if you don't have the information about the currency, whatever, there are combinations that don't make any sense. Wonderful. So the compatibility challenge, let me check the time. Okay, yeah, good. The compatibility challenge. So how about this question? Because this is even more interesting. It's more or less what Scott was, where he was bringing us. This question, sum of sales amount by supplier's country. Does it make sense? Does it not make sense? It depends. The answer is it depends, but I didn't come until Hanover today to tell you it depends because it's too easy. I came here to tell you I want to find the solution to that question with the help of a graph. So we cannot answer this because it depends on the data model, which in turn depends on the business processes. It's a long story. But basically, if I have the data model with that particular data set organized like this, with these keys available, then I probably know if that question is totally useless, totally wrong. So a bad question is a question that doesn't have any business meaning. So I want to find this answer. So what can be the solution to this problem? So now this, I guess you know where I'm going because we are going to start part 3. So how graph theory can solve the problem? Okay, relax. Okay, first off, which graph type should we use? Opinions. It depends. I like that. Okay, let's go by raise of your hand. Okay, can you all raise your hands just to see if the hands are working? Okay. Normally I ask who is wearing pants today, but they are recording, so Okay, so who thinks that directed is the answer? Okay. Okay. Who thinks that undirected is the answer? Who thinks that it depends? Okay. I personally think that directed is the answer, but again, that's my opinion. That's why we have coffee breaks, right? That's how it works. So the direction is given by the relationship type. My opinion is that if you model it as undirected, you are not keeping into account the precious information about the relationship type. If it's one-to-one, life is easy. But if it's one-to-many, well, there's a thing that I wrote in my book, a thing called fun trap. So there are things that when you mix a measure with something that is exploding that measure, well, it's not exactly the best. So my opinion is that directed is the way to go. And once again, what happens if you choose the wrong type of graph? So as we saw earlier, that the car, the navigator says turn right and it's a one-way. That's the type of incident that happens if you choose the wrong type of graph. So let's say that if I am right and directed is the way to go, and we choose to use undirected graphs to model a data model, well, that's interesting. What happens? I could really speak 7 hours about this and business objects. So business objects, I started with business objects in 2001 and I was working many years on that, basically was modeling data models with the logic that behind the scenes, I suppose, was based on undirected graphs. And business object was calling loop a thing that, in my opinion, was a legitimate question, because it was looking at a thing that was, you were going to able to the same point, so it was saying it's a loop. But there are cases when two fact tables are sharing 2 dimensions, so they both point to the same 2 dimensions. That for business object is a loop. For Astrato, the software that where I'm doing R&D, for us is not a loop, because we model data models with directed graphs. Again, opinions. So many-to-one scenario, the convention, the arrow goes from the many to the one. Super simple. A as a foreign key, B is a primary key. When I say foreign key and primary key, I don't mean that they are enforced. Foreign key, let's say primary key is the unique identifier of a column, and foreign key is the column that points to that column. So, or set of columns if it's a composite key. So when you have a many-to-one scenario, it's super easy, because basically the arrow goes from the foreign key to the primary key. As simple as that. You can't miss it. You can't fail it. And this covers 99% of the cases, because in a data model, when you see a schema, well, it's normally all one-to-many joins or many-to-one joins, depends which way you watch it. And there are sometimes others, but this is covering the vast majority. That's fine. So this is, for example, again, this slide, it's Microsoft AdventureWorks, and each of these arrows is actually following this convention. So every time that you see an arrow, it's because it's going from a foreign key to a primary key. You can watch the entire thing. I know it's all by heart. And all the joins are like that, because in that particular database, there is not even one-to-one relationship. Then, many-to-many scenario, it's even easier, because the business users will not be allowed to join them. So if you give a self-service environment to the business users, you don't want them to make many-to-many joins. And let me be clear, when I say self-service environment of data analytics, I don't mean that it solves all the questions. We want to build something that is addressing most of the business questions, and can be even up to 80–90% of the business questions. So you make people happy in 90% of the cases with something that is automatic. But that operator that was pressing the button on the lift, well, that operator still has a job, because he's staying in the company, he or she is staying in the company to address that 10% of difficult business question. And that's actually what makes his or her job more interesting. So this said, I'm saying never give to the business users the chance to create many-to-many joins, because if they need something that is so particular, you better call the operator. Okay. So just don't let them join. Okay, last scenario, one-to-one scenario. It doesn't matter too much. My personal opinion, but that's very arguable, is that in this case, it's usually possible to understand which table searches info from the other, and the arrow comes as a consequence. It's a bit the idea of the VLOOKUP. Even if you have 2 Excel sheets and you're VLOOKUPing from one to the other, well, from one to the other. So the arrow goes from the one where you write the VLOOKUP to the other where you are VLOOKUPing. Sorry for talking about Excel. Sorry, someone will not be happy. Okay, then I put a screenshot of Oriented Data Model Convention. It's a long text, I'm not reading it all, but the bottom line is that according to the ODM convention, which is my name, so it's a name invented by me, it's a screenshot from my book, the arrow is always oriented from left to right. This is a thing that I strongly recommend to everyone, the arrow oriented from left to right. And you say, why would that matter? Look at this. This is clearly not following the ODM convention, and you can still survive. You can find information here. But when you put all the arrows from left to right, you have an immediate information, because if you look at the table, everything that is on the right is uniquely derived. So if you have sales and you have all the tables on the right, well, these are all things that you can left join to that table. While anything that is not, that is on the left, if you can join it, but you will have duplications. So it's just a trick for having a faster reading, more intuitive reading. And okay, so this is from the Unified Scheme. This is an example of a data model. Time is looking good. This is the example of a data model. It's a data model that I created as a test database, and we should spend a minute to watch it, because my recommendation when you have a data set, just don't start coding. Watch it. Watch the keys, watch the column format, watch if the column names are coherent with what is inside the column. That watching data to me is the Bible. Okay, so we have a table of sales, and here on the left, so it's many. So you see how fast it is. You have sales. On the left, you have returns and shipments. Means that a row of sales can have potentially multiple returns and can have multiple shipments. Makes sense, no? It's super common. That's how SAP is organized. Very easy. Now, yeah, no, okay. Actually, on the right of sales, you have clients, you have products. On the right of products in this database, you have suppliers. And that's it. That's what you have on the right of sales. So for each row of sales, you will have, for sure, at most one client, one product, and one supplier, unless you have duplications of primary key. But that's an error of data. Fine. And then there is this funny table, client complaints. So I don't know what it is, because I'm new to the company. I was hired today, so I don't know. But because I'm watching the data, I immediately see that it's something that has information, who is the client who has complained. Okay, I know that. But I'm assuming that probably, if it's a website, for example, it's a form where someone is writing a complaint, but they don't have a drop-down menu to tell which product they are complaining about. They don't have a drop-down menu to say which employee they are complaining about, because if they had that possibility in the front end, it means that you would have here a foreign key that points to products or a foreign key that points to employees. So because data is organized like this, I didn't do the database. I am arriving at the analytics phase. Data is like this. That's how I see it. I can even investigate if the data warehouse has missed something, so I can check the source. But it's quite easy. At the end, I see, OK, client complaints is just a form where a client is writing some text and submitting. That's my way of interpreting data. Purchases. So a product has multiple purchases. Imagine it's a trade company. They are buying from vendors and selling to clients. So the same product can be bought multiple times, and then it can be sold multiple times. So this is what in my book I call a chasm trap. So it's a chasm trap is anything that has, if you do with the right hand, you do a V like that, that's a chasm trap. When a table has two tables on the left, that's a chasm trap, as simple as that. Because I can use the word left and right, because I am saying, let's organize data as an oriented data model. In the moment when you do oriented data models, what's happening? When you do oriented data models, the data is easier to watch. For example, you are detecting the fun traps and the chasm traps very easily. Yeah, it was just to make you move. OK. I like to create a bit of tension. You know, the first time that I came here to Hanover, I gave to Sandra my presentation just 1 minute before, because that's my tradition. Yesterday, this one I gave it yesterday evening, but the first time I gave it to her like 5 minutes before my presentation. She recommended don't do last minute, but it was 5 minutes, so it was not last minute. And because I am, okay, they know me now, but they didn't know me then, so she started the slide, okay, and it was the first conference that they were doing. Okay, all the audience ready, like you? Sandra, it's not the right presentation. she went total panic. Sorry, but I will do it again. Okay, so fine. So basically, everything is here, and especially the warehouse. That's the most interesting. So before the change, so the products and the warehouse. So basically, that's possibly one-to-many, because the same product can appear multiple times if the table contains multiple snapshots, for example, with a snapshot date. But again, so that's the place where you would have your stock amount, your stock quantity, sorry. Okay, so now look at suppliers. So in this data set, suppliers is a direct consequence of product. So in product, you have the key of product supplier that points to suppliers. You must say, okay, how does that differ from all the other things we have seen so far? Well, to me, this is quite relevant, because in some companies, it's like this. In some other companies, it's like this. So it could be that the information about the supplier is at purchase level, which means that you can have, and many companies have this business scenario, you can have a product which you bought from a supplier in Germany, or the same product, almost the same, you bought it in China. You give it the same code, although probably the quality is different. So this is quite relevant, because you remember the question that I was asking you earlier today. I was asking you, sum of sales amount by supplier's country, right? That one. Is it legitimate or not? Well, in my opinion, if the database is organized like this, it's a bit of a mess. Because, well, sales amount, okay, you know for sure for each row of sales, you know the product, but then you don't know anymore for each product what is the supplier, because there can be multiple suppliers. So you have to join with purchases, but that join will create an explosion of the rows, because the same product is appearing multiple times, because you purchased it multiple times. So you don't have that information if it's all like that, if the data warehouse was built correctly and everything. So watching data also means watching where the foreign keys are, and from that understanding most probably how the business processes are. Of course, you need to verify these things by going to the business and saying, does it really work like that? Yeah, we have the same product from both Germany and China. Okay, fine. So you also confirm that the business process is like that, so I'm fine. Because if we go back and we look at this, yes, you can, okay. If we look at this, to me, that question is totally legitimate. Sum of sales amount by supplier's country. It's fine, because each row of sales amount can have at most one product, typically it has it, unless you have orphan values, and each product has a supplier. So it's more or less like if it was all in one table. You can easily denormalize these three tables into one, and you don't duplicate the numbers. You know, my obsession, whoever has read my book, my obsession is about the duplication of numbers in fact tables. I would phrase it differently, but let's see it like that. So sum of sales amount. Okay, so that amount, if you have a scenario like that, does not explode. Well, if you have a scenario like that, you do the joins like this, it will explode, because you will have, for sure, for each product, you have multiple purchases, unless you opened the company yesterday. So this is an example of how I use data models for understanding data. And guess what? Now we are getting to the final, like there are 2 slides left, and I wanted to do a bit of brainstorming here, because we saw a few things, and now I really need your focus on these 4 questions, 4 business questions. So remember the girls at the top floor, the one that is not in the basement, the girls who are dragging and dropping data. So we want to give them the freedom to drag and drop whatever they want, unless it's a bad question. So you will tell me what you think about, and I'm very happy we have this break after this. You will tell me what you think, but my understanding is that some questions are bad. So really, you cannot put these two things together. So what we did in Astrato, basically, we designed a solution that is using graph theory, and for any combination, and again, back to the topic of all the combinations that you can have, well, for any combination, it's telling me if it's working or not with an algorithm that we are now trying together to find, because I want to see if you arrive to my same conclusion. And it's thousands or even more of combinations, but it's calculated on the fly, because graph theory, if you apply it to metadata is never big. How many tables you can have? 20,000, 100,000 tables? Well, for a database, a calculation of graph theory on a metadata of 100,000 tables, 1 million columns, it's still totally doable in almost real time. So it's not a big problem. So sum of sales amount by client's country. Sales amount is in sales. Client country, I guess it's an attribute here. I put it in green because I believe it's a legitimate question. I think most of you believe so, because that's what we do every day. Sum of stock quantity by product category. So product category is here. So stock quantity is here. Now, the ones that I consider bad, sum of stock quantity by client's country. So stock quantity is here. Sum of sales amount by supplier country. We have now this case where the supplier is not a direct consequence. You see, I strike through. So the supplier is not a direct consequence of product, but it's here. Okay, so in my opinion, the first two are legitimate, and the second two are bad questions. But it's still a business opinion or something that is not defined. So are we able in the next 3 minutes to find a method that teaches to a computer, a method that we can code in Python, in Angular, whatever? Actually, we are in Astrato, we are using Golang. So it's programmed in Golang. So why is it turning off? So I want to see for these 4 questions, if any of you is able to find out why the question is a bad question. Reminds me like the operator. Thank you. Okay, so there is such a silence that I can hear the water. How can we teach our programming language that the first 2 are good questions and the last 2 are bad questions? I want someone to guess it right now. Please raise your hand.
If you can cross the graph following the arrows, then you can't really join them in the right way.
Why did I tell you to come to this conference? Anyway, most people didn't hear you. Okay, so did you hear what he said? Some of you, yeah? Okay, that's the one that I consider to be the solution. So let's phrase it the way how I like, but that's what you said is totally correct to me. So it's about the concept of reachability. So you have vertices, and in a directed graph, not necessarily each vertex can reach each other vertex. The way how a graph is organized, we can even go back, I think it's several slides, and with this it will take 7 hours actually. But okay, I can do it. Maybe I'll do it with this. If we watch the graph, it's important this. So reachability, you see that 3 can reach 2, but 2 cannot reach 3. I'm talking about the directed graph, of course. So reachability is a concept that is super intuitive. You can give it to a kid. So you can only, the rule is you can only follow the arrow. Are you able to go from 3 to 2? Yes, I'm able. Are you going to go from 2 to 3? No. So the concept of reachability is a super general concept of graph theory. And based on this concept, I gave my way about the general rule based on reachability. So almost this is almost the last slide. So I call this bad question of type 1, because now we had 1 hour. I think it was quite already full of chats, but there is much more. So we were working several months, and we figured a few more types of bad question. But bad question of type 1, you have it when, okay, a measure and a dimension form a bad question of type 1 when the vertex containing the measure cannot reach the vertex containing the dimension. We have tried this on a million examples, well, not a million, on a few examples, and it works. Actually, because I did it with Astrato recently. That's the story of my life. I was always thinking in these terms. Maybe not from 2001, but after a few years, I said, come on, it's always the same. The rule is always the same. 1 to many, blah, blah. So the number must be able to reach the dimension. So simple. This is easy to implement in Golang, because in Golang we have library. And the people who write the library, they don't know how you will use that library, that function that is in the library. So they think that you might use it for Google Maps or for social media or for modeling a data model. And that's what we did. So basically in Golang we have the code that says, okay, this measure can reach the dimension, so it's legitimate. And then what is the use case? The use case is that whenever a user is making a first choice, drag and drop, I drag and drop sum of sales amount. Some of the dimensions are immediately grayed out. Still usable. If they want to use it, they can, but at least we gray out. So they drag sum of sales amount. Okay, so everything that is not reachable as dimensions will be grayed out. So all the columns that are here, 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 and let me tell you also here, they are grayed out. Because it doesn't make any sense to do sum of sales amount broken by dimensions that are here. However, you can always put another measure. No one says that your report is one measure and one dimension. You can have two measures. I want to compare the total sales with the total amount shipped. Fine. So only the dimensions will be grayed out, but you will have the freedom to take measures from many more places. All of them? No, but many more. For example, you can take them here, here. So, but you cannot take them from here. Well, the measures, we went a bit beyond. There are two types of measures, the ones that are resilient to duplications and the ones that are not resilient to duplications. So that's a long story. So we go to the last slide, and this is just a teaser. So I read very quickly to you. This is stuff that I didn't cover. So yeah, the Chinese spy is taking a photo. Okay, so NRTD measure, so like sum of sales amount. NRTD measure, non-resilient to duplicates. Sum of sales amount is not resilient to duplicates. You duplicate it, your report is wrong. NRTD measure and the dimension form a bad question of type 1 when the vertex containing the measure cannot reach the vertex containing the dimension. This we know. Then, bad question number 2. Two dimensions form a bad question type 2 when they do not have a common ancestor. What is a common ancestor? You can even Google it. But this, believe me, works. If they don't have a common ancestor, which is pretty much a common root of the tree, well, you can do a query of them, but you're creating Cartesian combinations. This is what I call a chasm trap. RTD measure. So RTD is interesting. So NRTD, sum of sales amount, anything that has some average, and this, actually the aggregators are non-resilient to duplication. But some other aggregators like count distinct, you can duplicate the client ID. So if you do count distinct client ID is a RTD measure, is resilient to duplications. So the restrictions that you do for RTD measures are less strict than the ones that you do for NRTD measure. So RTD measure still has some restrictions. It forms a bad question of type 3 when the vertex containing the measure cannot be reached by any root of the query poly tree. So there will be many things to say, but a query is not based on a tree. is based on a polytree. What is a polytree? Wikipedia will tell you. A polytree is a set of trees that are somehow connected. An NNA, another thing totally invented by me, doesn't exist anywhere. No one talks about this NNA. NNA stands for non-numeric aggregations. In Astrato, they were making the mistake that anything that has an aggregator was treated as a number. So you were allowed, I hope they fixed it, you were allowed to drag and drop max of client name as a value to put in a line chart. And I said, guys, not because you are aggregating is necessarily a number. It's two different things. So an NNA is a non-numeric aggregation, and it is pretty much following the same rule as a RTD measure, the same identical rule. It forms a bad question type 4 when the vertex containing the NNA cannot be reached by any root of the polytree. Last but not least, the filter, because also the business uses not only they drag columns, but they can also drag filters, conditions. So a filter forms a bad question type 5 when the vertex containing the filter is not in the WCC of the query polytree. WCC, it is a weakly connected component. It's just to make you understand very quickly what it is. If you have two blocks that are connected by nothing, they are two connected components. So they are two continents distant with the sea in the middle. So WCC is basically a weakly connected component is that equivalent concept with directed graphs. So it's a block of islands without water in the middle, islands that somehow are connected. Maybe you go only one way, but everything is reachable somehow. So a filter forms a bad question type 5 when it's basically in that group of tables. I didn't write this slide to be understood here. That's a teaser. That's why I called it teaser. It's just to tell you how much there is, how much work must be done to make things possible for self-service business intelligence. And this is only addressing one problem, which is the problem of the incompatibility. Then there are other problems of multiple options to join two tables and more and more. So that's, in my opinion, the reason why self-service business intelligence doesn't exist. Then, last question is, well, is it possible to give a full self-service business intelligence? In my opinion, no. But at least if you improve it from 10% of the options that you have now to probably 80%, I believe that this is a big thing. So that's all from me today. Thank you so much.